Okay, so we're going to look at using trigonometry to find missing angles in right-angled triangles using SOH. SOH is a really handy tool. Write it on your page. It helps you remember the identities. So the first one, S stands for sine. In short, it's SIN of whatever your angle is. It can be a capital letter. Usually it's Greek letters, but it could be anything. And O over H. That's where we get the SOH from. The C and CAH stands for cosine, and short for that is cos. Again, we can put a symbol and it equals A over H. That's where we get the CAH from. And last but not least, we have T for tangent, which is tan for short, and you can again put your symbol for the angle and it equals O over A as given in TOA. Now let's have a look at what this all means. If we have a look at a right angle triangle, the hypotenuse, or H, is always opposite the right angle, or it's the longest side of the triangle. The adjacent and opposite depend on what angle you're using at the time. If I'm using this one, then my opposite is the line that is opposite that angle, as though they're looking at it. And whatever is left is the adjacent. So if I was using this angle instead, and I'm looking out, the line opposite that is here, and this would be my adjacent. So it's dependent on what interior angle you are using. So let's do one by first labeling the diagram. Opposite the right angle is always the hypotenuse, and this is the angle in question, which means the 7 is my opposite. So I'm using O and H, and remembering my SOH, the one with O and H is sine. So let's use that for this triangle. So sine, we don't know what the angle is, so you can put whatever symbol you like. I'm going to use beta. So sine beta equals O over H, because that's SOH, opposite over hypotenuse. Now my opposite is 7, and my hypotenuse is 8. Now the difference here when finding the angle, so the angle isn't known, is we now have to use the inverse of the identities. So sine -1, you'll find this on your calculator, of 7 over 8 is equal to my angle. If I put that in my calculator, I get 61 degrees. Here is another example. Again, we're going to start by labeling it. So opposite my angle is my 80. This is my hypotenuse, if you want to label that, so that must be my adjacent. But I'm not going to use this, because I have a given here and a given, and here is my unknown. So I have O and A. Looking back at my SOH, O and A is in my TOA, or tan. So we'll write that down. Tan A, I'll use a capital letter this time, is my opposite. So my opposite is 80 over my adjacent, which is 23. Now we don't have the angle, so we have to use the inverse function. Tan -1 of 80 over 23. So this is in your calculator, and that equals my angle A. So you plug that in and you get 74 degrees. Okay, one more. Let's do our labeling. We have our hypotenuse, our longest line, or opposite the right angle. This would be my opposite if it existed, but it doesn't, which means this is my adjacent. So I'm using H and A. And if I have a look, the one with A and H is cos, or CAH. So write the identity. Cos of my angle equals A over H, so 26 over 50. We don't know the angle, so we have to use the inverse function of 26 over 50. Enter that into your calculator and you get 59 degrees. So in summary, make sure you label your triangle with OA and H, determine which identity you need to use, and lastly, substitute what you have and solve.